Welcome to the Signal Chain Designer quick overview. We are on our first page here. We've got a bunch of examples, but I'm going to start from scratch here. So the first thing that we do is we pick the source that we want to measure, and this gives the Signal Chain Designer tool some information about the bandwidth of the source, the output impedance, and so forth. If we wanted to change the output impedance of the source, we can go change it here. And you can see how that affects things like the bandwidth, that affects things like the noise, so forth. I'm going to go change it back to that 1K. The other thing of interest here is this measurement region. And so if we change this measurement region to whatever is of interest to you, it just gives Signal Chain Designer a little bit more information about what you care about. And there's a few places in the tool where it makes decisions based on the measurement region that you gave it. So this is the region that you care about, and then you set the bandwidth with these two here, so the bandwidth here. Okay, but let's get to the good stuff here. So I'm going to use this source. So here's our sensor over here, and now I'm going to go drop an amplifier. If I put in a gain of 1, it'll give me a simple buffer circuit. If I put in a gain of -1, it'll give me an inverting circuit. If I put in, say, a gain of 4, it'll give me a non-inverting. I can put in, say, I want a level shift, for example. So I can do all these things. Let's just go and make a simple gain of 10 circuit. So here's the bandwidth for this particular amplifier. I could go click on this guy to go change the amplifier if I wanted. I can go look at things like the input impedance of the circuit, the output impedance. I can go look at our noise. I can look at, let me refer this to input, and then I could go look at the various components of the noise. I can see how those, if I change the resistor, so I'm changing the absolute value of the resistors without changing the ratio, I can see how those things change. I can go look at things like DC error, input range, power, so forth. So let's say I've looked at those various things. I'm happy with the circuit that I chose, so I'm going to say use this amplifier. So now let's say I want to drive a differential ADC. So if I'm going to drive a differential ADC, I'm going to need a single-ended to differential converter. So to do that, I click on that little guy, this little triangle right here. So I make that. I'm going to put in a gain of 1. So here it generates a circuit for me that's a single-ended differential converter with a diff amp. I could use an op amp configuration, or I could use an in amp configuration. Let's say I'm going to use this op amp configuration. I also want to make sure that my common mode output is about the mid-scale of what my ADC is going to be. And again, I have a bunch of graphs if I wanted to look at various graphs here. I'm going to use this amplifier. Now I'm going to go drop an ADC. Let's say I want a 24-bit. Let's say I'm not going that fast, so I'm going to go 100 samples per second. And now I get this ADC. This is a sigma delta ADC. We can see it already has internal filtering here. So we can see that this is from the internal filtering. And then generally, nearly every ADC has some sort of anti-aliasing filter to cut down the noise in front. So we put the recommended filter from the datasheet there for you, and we put the recommended reference for you. You can, of course, go change those things if you wanted. This particular ADC looks like it's running off 2.5 volts. So one of the things that we might want to go do is we might want to go back to this differential configuration here and change this common mode out to 1.25 so that it's right in the middle of that ADC drive range, for example. Okay, and just like with the amplifiers, we can see the various performance of the ADC, see the various errors and power and so forth. So we've got this. Let's say we're happy with it. And as we've been plopping down these blocks, we've also been simulating the full signal chain. So here is the transfer function of the full signal chain. Here is noise from the full signal chain. So we can see, hey, look, the ADC has the most noise. That's typically what we want, so we typically want the ADC to dominate, so that's good. We can look at things like the DC error, see that amplifier 2 is the one that's contributing the most to our DC error, so if we wanted to work on that, that would be the spot to work on. We can look at things like power. Here's our power rails. We can look at it from a current perspective. So just like in the various smaller views for the stage views, we also can look at those same kind of views at the circuit level. We can also look at the circuit itself. So here is the circuit that we built here, stage 1, stage 2, and stage 3. So let's say we look through that and we're happy with that. So then we can go to next steps. We can export those graphs. We can export to LTspice. So I'm going to export to LTspice. Pull this up. So here is our design in LTspice. There's our first stage, second stage, third stage. So we can go further and do whatever edits or simulation we want in LTspice. The last thing that I want to show you is how to save. So every time that you come back to this main screen, this URL updates. So there's this step. So every time you come back to this main screen after an edit, that step is going to update. And so you can use this URL. You can just copy this URL and save it. Or when you're on, say, next steps, you can just hit save, share design, say copy URL to clipboard, and now just put that URL wherever you want, and that is how we save it. And so now I can go open a new window. I will paste that in the new window, and then this will load the new signal chain. This is like if I go make an edit here, this will not affect the design here. So you can feel free to send this to other people and not worry that they're going to go make changes to your design, or that, you know, if somehow it needs to be secret, you won't be able to see their changes and so forth. So that's how the saving works. Okay, that was a quick overview on how to use the Signal Chain Designer tool.